Hello everyone and welcome to this training session on the basic introduction to probability. My name is Vamsidhar. Qualification wise, I did my postgraduate diploma in management from Indian Institute of Management, Indore, and I am also a founder of an institution called PACE, which trains people in finance and analytics, various global financial certification exams like Chartered Financial Analyst, Financial Risk Manager, the Actuarial Sciences, along with skill based trainings in the area of finance and analytics using tools like Excel, SPSS, etc. As a part of this session, I would like to introduce you to the basic concept of probability. I hope all of you appreciate the fact that probability plays a very key role in multiple areas. Whether you talk about finance or risk management or any analytics space, probability has a key role to play. So, looking at it, we have introduced an introductory chapter which can help you both for test takers as well as people who would like to use this concept for practical applications. So to start with, when we have to define probability, we need to have a clarity on some of the terms. So in case I want a clarity on probability, I need to understand few terms. A random variable. Probability is more associated to uncertainty. Any particular event where the outcomes are uncertain, we try to use this concept of probability. For example, I toss a coin. I don't know whether I would be getting heads or tails. That is what I call as a random variable. Any variable whose values are uncertain. Let's say, would it rain tomorrow or not, is an uncertainty. So, whenever there is a scenario of uncertainty, I have taken an exam, would I be passing or not? I have taken 5 exams, would I be passing them or not? These are the instances of uncertainty in our life. Now, you can think of any space where you are working on, wherever there is a scenario of uncertainty, you can try to quantify that uncertainty using this concept of probability. So random variable is simply any particular variable whose values are uncertain and which can take multiple values. So whenever I toss a coin, my outcome can be head or tail, which I don't know, which is an uncertain. The value which the outcome will take is uncertain. So that is what we are calling as a random variable, and that is where probability plays a key role. And the various outcomes that particular random variable can take is what is called as a sample space. When I toss a coin, it can give me heads as well as tails. This is my sample space. Similarly, when I throw a dice, I can get 1, 2, 3, 4, 5, 6. This is my sample space. So, any particular random variable, the set of all outcomes that it can bring out is what we define as the sample space. And each specific outcome, I need to understand very clearly what comes when a particular experiment is done. When I toss a coin, what can come? It can be head or tail, which is a subset of this sample space. My outcome is a subset of this sample space. Now, what I want to track, let's say when I throw a dice, I want to know what is the chance of getting a number greater than or equal to 4, which means I can get either a 4 or a 5 or a 6. So what we are saying here is combining one or more outcomes which are more favorable to us. This is what we define as an event. An event is a combination of 0 or more outcomes which we would like to track. So for which we want to see what is the chance that this particular event can occur. So I can have any number of events which are the combinations of one or more, 0 or more outcomes. That is one more thing we have to be comfortable with. And then we can see if I take 2 events at a time, 2 or more events at a time, what I simply observe is these events, one can be mutually exclusive and or they can be non-mutually exclusive. We'll define. When I say mutually exclusive, if one of those events occurs, the other one cannot occur, and vice versa. For example, I define 2 events. One is getting an even number when I throw a dice. The other one is getting an odd number when I throw a dice. Now, when I throw a dice, the outcome will definitely be either an even number or an odd number. It cannot be both. In such case, I can call events A and B as mutually exclusive. Like when I throw a dice, I've defined an event A as getting even number. I've defined an event B as getting an odd number. Now, I'm very much sure that these 2 events are mutually exclusive. If A comes, B cannot occur and vice versa. In that case, I call them as mutually exclusive. Other than that, let's say if I have defined my 2 events as A is getting even and B is an event of getting a number less than 4. Now, when A occurs, B also can occur. They are not exclusive. If an even number comes, that even number can also be less than 4, which is 2. 2 is a number which is both even as well as less than 4. Which means this definition of A and B, these 2 events A and B are not mutually exclusive, whereas in the first case A and B are mutually exclusive. So we have to have a clarity first of all, whenever we are looking at 2 or more events, are they independent, are they mutually exclusive or non-mutually exclusive? Now, when they are non-mutually exclusive, there is one more classification for us. Are they independent or dependent? which means, okay, A and B are non-mutually exclusive, but is B dependent on A or is it independent of A? In some cases, what happens is the outcome of A has an impact on B. In some cases, the outcome of A does not have an impact on B. For example, if I am talking about getting an even number as well as less than 4, if I know A is even, the next event is if I'm tossing the coin if I'm throwing a dice 2 times. In the first case, if I have got an even number, first of all, there is no guarantee that I will get an even number in the second case. In that case, I say A and B are independent events. But if I get an if I get an even number in the first case, then if I say, if I know that it is an even number, what is the chance that it is less than 4? So that the less than 4 is dependent slightly on the additional information that is provided. In that case, we call them as dependent events. When two events occur without any kind of relationship between them, we call them as independent events. If they are not mutually exclusive, they can fall into either of the categories independent or dependent events. So some of the definitions we need to be comfortable with before we start defining our probability. Now, when it comes to the basic definition of probability, it is simply number of favorable outcomes divided by total number of outcomes. So whenever we have to talk about probability of occurrence of an event, I can look at it as number of favorable outcomes divided by the total number of outcomes. Suppose I say I throw a dice. What are the favorable outcomes? It can be, what are the total outcomes? It can be 1, 2, 3, 4, 5, 6. So I'll have total of 6 outcomes. Let's say I am defining an event A, getting a number greater than 4. What are the favorable outcomes there? 5 and 6. Two of them are favorable outcomes. So number of favorable outcomes divided by the total number of outcomes, it says that the probability of getting a number greater than 4 in the throw of a dice is 1 by 3. This is how we define the word probability. And as a basic definition, we'll always see that probability of any event will definitely lie between 0 and 1. 0 and 1 are inclusive. The minimum value of any probability is 0. The maximum value is 1. So 0 and 1 are both definite events. So if the probability is 0, I say that the event will definitely not occur. If the probability is 1, I will say the event will definitely occur, which is both are certainty based events, whereas any probability that is lying between 0 and 1, we associate it with the uncertainty. Right? Any example we take, it can fall either to 0 or 1 and anywhere in between. If we think that the outcome is uncertain, it will definitely between 0 and 1 and not 0 or 1. Zeros and ones are treated as a definite occurrence or a definite no occurrence of the event. Then we also need to understand another definition: complementary events. If I say, if I am defining an event A as getting a number greater than 4 in throw of a dice, then we know that the probability of A is 2 by 6 or 1 by 3. Then the complementary event for this is the negation of it. Sometimes I can write it as A complement like this or A bar. This means only one single line. This means not getting a greater than 4. So it just preceded by a not. We don't say less than 4 or something. It's a simple preceding by not getting greater than 4, which implies the probability of not getting greater than 4 is I can get 1, 2, 3, 4. So 4 of them are favorable out of a total of 6. So the probability is 2 by 3, which is nothing but 1 minus 1 by 3. So we can also write this as 1 minus the probability of A. So a complementary event, the probability of any complementary event, we can very well take it as 1 minus the probability of the main event. So which also gives us gives rise to another relation for us, that the sum of the probability along with its complementary term is always equal to 1. One more relation we have to be comfortable with. All right. So now let's move on to our next aspect. Here, if I want to look at combining two or more events, combining two or more events, this combination can be done with an AND condition, which talks about both events occurring together, or the combination can happen through an OR relationship where either of the events occur, or at least one of the events occurs. This is what we call as, this is how we combine two or more events. So what we want to find out is what is the probability of the combination, either with an AND or with an OR. Whenever the two events are joined with an AND condition between them, we use what is called as the multiplication rule of probability. And when both two or more events are joined with an OR relation between them, we use the addition rule of probability. So for example, when I am throwing a dice, what is the probability that I will get an even number and a number greater than 4? Even and greater than 4. Whereas here the question will be defined as what is the probability that I'll get an even or a number greater than 4. So theoretically, what are the outcomes here? Getting an even number means the outcomes could be either 2, 4 or 6. Getting a number greater than 4 is 5 and 6. So because the question is about and, which is about both, only commonality between these two items is 6. So there is only one favorable outcome out of the 6 favorable outcomes. So we'll write the probability of A intersection B. Intersection is a sign which is primarily used for and kind of a relationship. One favorable outcome out of the 6 total outcomes. So we say that the and relationship between A and B is 1 by 6. Whereas coming here, the getting an even number, the outcomes are 2, 4, 6. Getting a number greater than 4, the outcomes are 5 and 6. We are talking of at least one of them occurring. So the possible outcomes are the combination of all. So we don't duplicate the count. So there are 4 possible outcomes that are possible, because we are talking of at least one occurring, which means I'll not take the commonality. I'll take the outcome even if it is present in one of the events. So my probability wise, the P of A union B is probability of either A or B occurring. The number of favorable outcomes is 4 divided by the total number of outcomes is 6. So this is how actually we define the combinations of 2 or more outcomes. But yes, this is a simple question. So we were able to identify all the possible outcomes and trying to pull out the combinations or the total possible outcomes which are occurring either in one or the other. But sometimes the situations may be very complex. It becomes very difficult to identify the total number of outcomes and then pulling out the commonalities between the two. So if that's the case, it is always better to have a formula kind of a mechanism to extract the probability both in case of multiplication as well as addition. And that's the reason we have 2 or 3 different kinds of calculation. So I would again reiterate the formulas. I'll try to, this time we'll use the and formula for union and intersection. So going with the formula, if I have to define probability of A intersection B, it goes with a formula probability of A multiplied by probability of B given A has occurred. We'll discuss what it is. This is this kind of a term we call as conditional probability. I'll come to it. Or I can also write it as probability of B multiplied by probability of A given B. This is a formula for multiplication rule of probability. Similarly, if I am looking at the addition rule of probability, I can directly use probability of A plus probability of B minus probability of A intersection B. Okay. Now let's look at the addition rule. What is the chance of getting either A or B? So what it is saying is, I'll look at the chance, the probability of event A occurring. I'll also find the probability of event B occurring. But in this process, I would have counted the outcomes which are occurring both in A and B twice. I would have counted them both in, let's say we are talking about throwing a dice. Throwing a dice, events A is even number and B is getting a greater than 4. Now, when I want probability of A getting an even number, the outcomes are 2, 4, 6. So, favorable outcomes are 6, total out 3 and total outcomes are 6, 3 by 6. When I am looking at probability of B, the outcomes are 5 and 6. So, two favorable outcomes out of a total 6. Now, what is happening here? In this case, we have counted the outcome 6 both as a part of A as well as B. But in P of A union B, even in our earlier understanding, we did, though it has occurred 2 times, we have considered it only once, which means that duplicated part has to be removed. And that is what we are doing as a part of A intersection B. And in our earlier example, we have found that the A intersection B, which is the commonalities between both A and B, is 1 outcome out of 6. So that's how we have arrived at 4 by 6. Right? But what we may have to do is, how do I arrive at P of A intersection B? Now, intersection is both A and B occurring together. If I am talking about both A and B occurring together, either A can occur. First, A can occur. See, if I want 2 events A and B occurring, I should look at, yes, first look at what is the chance A occurs. Now, given A has already occurred, what is the chance B occurs? This is how we look at both of them occurring. Let's say I want to pick up a person who is the number of people who are having high IQ as well as good sportsmen. I want to pick up people in a group who are having high IQ as well as good sportsmen. So what is my simple way to do that? First I'll pick up the group who are having high IQ. Keep the rest of them aside. From this shortlisted group of IQ people, I will find out who are good sportsmen. Which means, given this group contains all people with only high IQ, out of this, who are the people who are good sportsmen? That's how we always find both the events occurring. So, what is the chance of the first event occurring? And given that the first event has occurred, what is the chance that the second event occurs? That is what we call as conditional probability. When I write P of B given A like this, it means assuming A has already occurred, it's a fact. Assuming that A has occurred is a fact, what is the chance now B will occur? This will primarily be applicable when B and A are dependent on each other. When B and A are not dependent, it's as good. If I say independent events, if the events are independent, we can simply say P of B given A is same as P of B, because B is nowhere dependent on A. Similarly, P of A given B is P of A only, because there is no dependence between A and B. But if they are dependent, depending on whether A has occurred or not, the probability of B changes, because B is completely dependent on A, or in some cases A is dependent on A. Then we should have number corresponding to the conditional probability of A and B. So for example, if I say the chances of unemployment during a booming economy is 5%, and the chances of unemployment during a recession economy is 10%. So the unemployment and economic state, they are dependent events, or unemployment is dependent on the economy, because my statement is the probability of unemployment in a booming economy is 5% or 0.05. Probability of unemployment in a recession economy is 10% or 0.1, which means given the economy is booming, the probability of unemployment is 5%. Given the economy is not booming, the probability of unemployment is 10%. In this case, unemployment and economy are not independent. If they have been independent, irrespective of whether the economy is booming or recession, the unemployment probability should have been the same. That is how we understand the dependent and the independent events. So the moment I know that they are dependent events, the combination can be obtained through P of A multiplied by P of B given A. Now let's see how we have arrived at this number using the formula. Now if I want the probability of both an even number as well as greater than 4. So probability of A, which is, what is the probability of getting an even number? 1 by 3 into probability of B given A, which means if it is known that A has already occurred, if it is known that the even number has already occurred, which means it is now the outcome set is simplified only to 2, 4, 6. Sample space has become a smaller sample space because it's already known that A has occurred, which means the even number has already occurred. So for B now, the sample space or the total outcomes possible are only 3, not 6. Now out of them, what are favorable for B? What is B? Getting a number greater than 4. Getting a number greater than 4 is only 6. 1 out of the 3, the first one is getting an even number. The probability is 1 by 2, 3 by 6. And so now only 1 out of 3 is favorable. So overall it is giving me 1 by 6, which is what we have obtained even in our direct case also. Now let's apply it as P of B multiplied by P of A given B. Okay. Now first, what is the probability of B occurring alone? Getting a number 4 greater than 4 is, the possible outcomes are 2 out of the favorable outcomes are 2 out of a possible outcomes of 6. So now assume that B has already occurred, which means the sample space now is only 5 and 6. Out of this, what is the probability of getting an even number? So even number, the favorable is only 1 out of the 2. So I'll write it as into 1 by 2, which will again take me to 1 by 6. So whether I write it as P of A given B or P of A given B or B given A, whether I take it as P of B multiplied by P of A given B or P of A multiplied by P of B given A, the intersection rule will give me the same value. The only difference is if both these events A and B are independent, then their multiplication rule is nothing but the multiplication of their independent probabilities itself, the product of their independent probabilities itself, because you try substituting P of B given A equal to P of B here, it becomes P of A intersection B equal to P of A into P of B, which is nothing but as if the two events are separately occurring, because they are no dependency on each other. So that is how we look at. And if our events are mutually exclusive, yes, we already know There cannot be any combination, because mutually exclusive is if A occurs, B cannot occur, and vice versa. So if they are mutually exclusive, the P of A intersection B will be definitely 0. So just to summarize these three situations: mutually exclusive, non-mutually exclusive, and dependent, as well as independent. In these three cases, let's say I want to find out P of A intersection B, and let's say I want to find out P of A union B. In case of mutually exclusive, in case of dependent events, as well as independent event. In case of mutually exclusive, the intersection is 0. In case of dependent events, it is nothing but P of A into P of B given A, which is also same as P of B into P of A given B. In case of independent events, it is simply the multiplication of their independent probabilities. Even if we have 3 or 5 events, all of them are independent, their multiplication rule is nothing but simple multiplication of their independent probabilities itself. Whereas when it comes to A union B, the formula will simply hold true. P of A plus P of B minus P of A intersection B, and we have seen that P of A intersection B is different for 3 different cases. So that's the only thing that will be updated here. So for mutually exclusive, it is just P of A plus P of B, because P of A intersection B is 0. For dependent events, I can write it as P of A plus P of B minus P of A into P of B given A, or vice versa. And for independent events, it becomes P of A plus P of B minus P of A into P of B. So these are some of the relations which you need to be comfortable with, and trying to assess whether the events which you are coming across are dependent or independent, and trying to compute the multiplication rule as well as the addition rules of probability. I hope this basic introduction is comfortable for you regarding understanding the basic concept of probability, as well as combining two or more events and trying to find out their probability of occurrence. If you have any further queries regarding this, you can very well feel free to call me on 919848012123, or you can even drop in an email to me at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.